Hi everyone, I'm Nenad Petrovic and I will present you my paper from area of philosophical issues of computer science. The paper's title is Computer-Supported Afterlife, Near Future or Far Cry for Human Race. At first, the mechanical machines, the so-called primitive computers, were able to solve only basic arithmetic operations. Later, in the 1930s, the theory of computation appeared together with Turing machines, an algorithmical way of thinking. Later, in the 1950s, people asked themselves whether these computers and machines will somehow show intelligent behavior. By considering the transhumanist visions, it's very optimistic that computers will be able actually to execute the mind data, and actually this way we can have afterlife. However, even if we have something like this possible, is it really a way to achieve eternal life? To restoring back all this information from the brain can actually have still the intentionality of the person who originally owned that brain, and have only just raw, or will just have a raw data that is transferred without any real human capability. How can we test actually this goal? These are the questions of my paper. So one possible approach to tackle this question is computation theory. So let's assume that we have a human, the so-called computation machine, which is actually a human, and on the other side, my a real computer that is executing some program. So both of them have their corresponding consciousness function, fx that corresponds to human and fy that corresponds to robot or machine. The question is, from perspective of Turing machines, whether is it possible to construct a Turing machine MZ that can be also performed by some computer and give us the answer whether the functions fx and fy are actually the same. So if we transfer this problem to program equivalence, we can restate the question like this. Does Turing machine MX compute function that constitutes the set Fy? From computation theory, we know that it's not possible, as there is no such Turing machine that can answer whether two Turing machines, MX and MY, that correspond to human and computer accordingly, actually calculate the same function. There is no such Turing machine, and the explanation is actually justified by Church's thesis, which states that actually there is no such Turing machine, and there is no something that is more powerful than Turing machine that can actually answer such problem. The potential solutions could be to provide more powerful computation model than Turing machine itself. However, Church's thesis actually states that it's not possible. It would be revolutionary, of course, as by reduction we would be able to solve some unsolvable problems that are standing like this for millennia. So what about Moore's law actually? Can it help us some way to achieve this goal? The answer is no, as it doesn't increase the computational power, just the computation speed. So we cannot just sit and wait for technology to achieve its progress that is high enough to solve the problem of computer-based afterlife. However, humans are not limited to problems solved by Turing machines, so it is really a question whether how this goal would be even possible at all. Another approach is physical approach. We assume that human beings and computers are two distinct physical symbol systems. The question is whether the consciousness can be present at both places at once. Fx and Fy, can these two be at the same place executed by both human and robot? So when it comes to quantum computing, it's a current trend where we have qubits which can actually belong to many states at once, unlike traditional binary values where we have only 0 and 1. Here we can have states that actually are both of them at the same time. However, is there an answer to our initial question in quantum computing? So there are some similarities when it comes to quantum computing with non-deterministic Turing machines and probabilistic computers. However, quantum computing does not increase the computational power of computers, but just the speed for some hard problems. However, it does not violate Church's thesis at all. So we have still the same limitations and the goal is not achieved. Finally, let's take a look at what would be the social, ethical, and legal issues even if we achieve this goal. So solving one of currently unsolvable problems would actually, if we break computational limits imposed by Church's thesis and Turing machines, would actually lead to solution of many other unsolvable problems as side effect, like breaking passwords, cryptocurrencies, and many other things that will actually make our lives uncomfortable. And who is going to be actually owner of this? And even if we are able to transfer someone's brain to a computer, who would be the owner of someone's digital life? Also, the question is, what if someone doesn't want to be transferred to computer at all? So, is person living this way within the computer actually still responsible, and how is he or she responsible for her or his behavior and actions in terms of legal acts? So this innovation is actually potentially very dangerous and can bring us really many problems than actually true benefits. So the conclusion is that due to computational and physical limitations, computer-based afterlife utilizing brain information is still not achievable. The key is breaking the Church thesis, actually finding computational model more powerful than Turing machine, but it's not possible at all. So even if this happens one day, it will bring us really more struggles than real benefits. Thank you for your attention.